Hiya, so in this video we're going to be looking at the CPU, which is the central processing unit, and we're going to be able to explain what the CPU does. We're also going to look at the main parts of the CPU, and we're going to briefly look at the von Neumann architecture. Okay, so CPU stands for Central Processing Unit. Okay, you may have heard that before. The CPU is sometimes considered as the brain of the computer system because it basically does all of the processing. It processes the data and the instructions. They're all needed in order to make this system work properly. Okay, so some of the factors that may affect the processing power of the CPU include the clock speed, the number of cores, and the size of the cache. Now we're going to actually look at these in a later video. Okay, we've also got a term here known as CPU architecture. Okay, now this basically describes the way that the CPU is built and how the CPU components such as the control unit or the arithmetic logic unit, which we're going to look at, how they interact with each other, how the CPU interacts with, say, the RAM, and various other parts of the computer system. Okay, so the three main parts of a CPU that you need to know are the control unit, the arithmetic logic unit, and the cache. Okay, these are the three main parts. Now for AQA you also need to know the clock and buses. Now we're going to briefly go on to those at the end of this video, okay, but this is for both OCR and AQA GCSE. Now you also have something known as a register, and registers are used to hold bits of data just on a temporary basis until they're needed again by the CPU. These registers are very, very fast. They are used to read and write inside the CPU, and they are the quickest type of temporary memory that you will come across inside the CPU. Okay, so the first of these main parts is the control unit, and what the control unit does is it basically takes overall control of the CPU. It basically will execute the instructions and tell the data where it needs to go and when it needs to be there by, and it follows something known as the fetch, decode, execute cycle here. Now we're going to look at that in the next video, and that's also to do with the CPU. Okay, we've also got the control unit, which controls the flow of data inside the CPU to the registers, the ALU, and the cache, and it also controls the flow of data outside of the CPU that goes to the main memory, such as RAM, or the input and output devices of your computer system. Okay. Next, we've got the arithmetic logic unit, or the ALU, and basically this one does all of the calculations. Okay, so this includes addition, subtraction, comparison between two numbers, sees which one's bigger or smaller. It can do multiplications and divisions, and it does this by using repeated addition and subtraction. So for example, for 5 times 9, it will add 5 lots of 9 together. Okay, so we'll do 9, add 9, add 9, add 9, add 9 until it gets the answer. Okay, it also performs logic operations such as and, or, and not. So if you've come across logic gates before, it might do these. It'll also do binary shifts, because obviously a computer processes everything using binary. Okay, and it also contains the accumulator register. Now the accumulator I like to think of as the temporary equals box on your calculator. So when you add up two numbers and you press equals, and it comes up with the answer, and then you can sometimes press just straight away press plus and then another number, and it says on your screen ANS, which is your answer, plus whatever. That ANS, which is your answer, is like the accumulator. It's your temporary storage of whatever the sort of running total is, and it will keep that there, and it will keep adding and taking away or multiplying whatever to that answer box. Okay, so that is the accumulator. Next, we've got the cache. Now, The cache is a very, very fast type of memory inside the CPU. It is a lot slower than the registers that we talked about before, but it's a lot quicker than RAM because the RAM is outside of your CPU. Okay, what the cache does is it stores regularly used data that the CPU can access quickly. Basically, if you think about this as whatever programs you have recently opened or that you use a lot, it will then store this data in there. So for example, if you're always using Google Chrome or you're always using Microsoft Word, it will then keep these sort of stored there, and then whenever the CPU requests this program or the data, it will check the cache to see if it's there. If not, it will go and fetch it from RAM. However, if it is there, it's obviously a lot quicker and it can boot it up and start the program a lot faster. However, one of the problems with a cache is they have a very low capacity and they're very, very expensive compared to RAM and your secondary storage like your hard drive or your SSD. So that can be a problem if you want a really, really fast sort of CPU. Now, CPU cache have different types of levels. So we've got, as you can see here, L1, L2 and L3. Now L1 is the fastest type of cache memory, however it's got the smallest capacity, so it can't hold that much. L2 is a bit slower than L1, but it can hold a bit more, and L3 is a little bit slower than L2, but again can hold a little bit more. Okay, so what we've got here is a diagram of the CPU with all of the components and parts of this CPU labeled. So as you can see, the three main parts we had the control unit over here, the ALU over here, and actually the cache is sort of down here somewhere because it's a memory. So it's like sort of, this is your RAM, but it's kind of here because it's just inside. Okay. Inside your control unit, you've got something known as the program counter. Now this basically holds the memory address of each instruction per cycle. So it basically keeps track of where in the list of instructions is the CPU up to. Is it at number 10 or is it number 20, number 30? If it's at number 30, what does it need to do next? It basically tells the sort of whole CPU where it's at and what it's going to go on to do next. Okay. You've also got the accumulator. We briefly discussed that as sort of the temporary equals box that holds the results of your calculations. Over here in your registers box, we've got the MAR and the MDR. Okay, now the MAR is used to hold the address. Okay, and that is basically the location of the data. So wherever the data is stored, somewhere in RAM or in the cache or anywhere, it basically finds the location of it. Okay, so it's the address. So think about location like address where you live. That is a location. Okay, it's the same with data. It's also stored in a location. Okay, we've also got the MDR, which is the data register, and this actually holds the data or instruction. So this is actually what's going on. So if you think about the address, it brings a box to the house, puts everything in from the house in it and brings it back, and the stuff inside the box is the data. Okay, and whatever's inside the box is not read by the address register, but the stuff inside the box is read by the data register, but the stuff on the outside about where it lives or where its location is not read by the data register. Okay, so they all have sort of separate jobs. Okay, so what you can see here in front of us is the diagram of the von Neumann architecture. Now there is also another very popular architecture known as Harvard architecture, but you don't actually need to know about this for GCSE. That is an A-level topic. Okay, so I hope this has been helpful. Hopefully you now understand the CPU a lot better.